Hello and welcome to my video. So for today's video, we will be solving a problem from a book called Vector Mechanics for Engineers 9th edition in chapter 3 Rigid Bodies Equivalent System of Forces 24th problem. So the problem states a wooden board AB which is used as a temporary prop to support a small roof exerts at point A of the roof a 57-pound force directed along BA. Determine the moment about C of that force. So, the problem asks us the moment C of which a force is exerted at point A. So, to solve for the moment C, we will be using this formula, which is MC is equals to RAC times FBA. So, RAC is the distance of point C to point A, and force AB is the force which is exerted at point A. So first thing that we are going to do to find is the RAC. So to find RAC, we must first take a look at the figure earlier in 3D perspective. So as we can see in here, we have our 3D version of the roof earlier. It doesn't look like the roof, but I just make it just to make it more simple to look at. So as we can see in here, we have the black line which represents the distance of point C to point A, and we also have its components from Z axis, Y axis, and the X axis. So what we are going to do with this figure is that we are going to find its components. So going back in here, we take a screenshot from our figure earlier. So still, it has the distance from point C to point A along with its components in Z, Y, and X axis. We also take a closer version of our main figure, which is here. So as you can see in here, we have these values. So these values will be used later on to find the components of RAC. So the first component that we are going to find is the X axis. So to find the component of X axis, it must first line with the X axis. So as we can see in the figure, it is very clear that the value of the X component is 48 inches. So next component that we are going to find is the Y component. So as we can see in the answer, we have a negative 6 inches. So first take a look at this figure here in this 3D version. So as you can see, the line is pointing downward, so therefore the value of Y is negative because it counteracts the direction of the Y axis, and also because it lies below the Y axis. So next component we are going to find is the Z component. So the Z component is equal to 36 inches. It is also very clear in the figure that the value is 36 inches. So now that we have these values, we are going to arrange it to be used later on in finding the value of MC. So arranging this, we will get RAC is equals to 48 inches I hat, which represents the X component, minus 6 inches J hat, which represents the Y component, and 36 inches K hat, which represents the Z component. So now that we have the value of our AC, its components, next components that we are going to find is the FBA. So in finding the components of FBA, we will take a look at this in 3D perspectives. So as we can see in here, we have our 3D version of our figure earlier. So this is the force that is acting on point A. So this is force AB. So what we are going to do with this figure is that we are going to find its components from the Z, Y, and X axis. So but first take note that the force is going upward, so therefore our value for the Y axis later on should be positive. And let's take a look at this side. So as we can see in here, the arrow is going the opposite direction of the Z axis, so therefore our value for the Z axis later on should be negative. So as we can see in this side also, the force is going also the opposite direction of the X axis, so therefore our value of the X axis should be negative. So going back in here, we are going to find the components of our FBA. So as we can see in here, we have our figure because this will be useful in finding the components of FBA. So to find FBA, we are going to use this formula, which is unit vector BA multiplied by force BA. So force BA right here is the given force from the problem. So to find our unit vector, we are going to use this formula, which is x plus y plus z over the square root of x squared plus y squared plus z squared. So x, y, and z right here are the components of point B to point A. So what we are going to do with this formula is that we are going to find its component. So as we can see in here, we have the components of our point B to point A. So in the x-axis, we have negative 5 inches. So as we can see in here, the figure, we have 5 inches. It is negative because the direction of point BA opposes the direction of the x-axis. And in here, we also have 90 inches in the y-axis, which is very clear in the figure. And lastly, we have negative 30 inches in the z-axis. But as we can see in here, we have known 30 inches in the figure. But what we did is that we subtract 36 from 66 since point A does not rest on the wall, which distance is 66 inches. So we need to subtract it to get the z-axis of our point B to point A. So by subtracting 36 from 66, we will get 30 inches. It is also negative because the direction of the force BA opposes the direction of the z-axis. So therefore, it should be negative. So since now we have the value of our x, y, and z components, next thing that we are going to do is that we are going to substitute it to our denominator. As we can see in here, it is already substituted. So what we are going to do with this is that we are going to simplify it. So simplifying our denominator will get us 95 inches. And next thing that we are going to do is that we are going to multiply 57 pounds to our numerator. So as we can see in here, we have distributed 57 pounds to our numerator. So our FBA right now is equals to negative 57 pounds multiplied by 5 inches in I hat plus 57 pounds multiplied by 90 inches in the j hat minus 57 pounds multiplied by 30 inches in the k hat all over 95 inches. So if we are going to simplify our numerator, we would get this equation, which is negative 285 pounds inch in the I hat plus 5,130 pounds inch in the j hat minus 1,710 pounds inch in the k hat all over 95 inch. So if we are going to furthermore simplify this equation, we will get our components of FBA. So by dividing the denominator from our numerator, we will get these components. So our components of FBA is now equal to negative 3 pounds in the I hat plus 54 pounds in the j hat minus 18 pounds in the k hat. So since now we have the components of our RCA and our FBA, we can now find the value of our MC. So to find the value of our MC, we are going to form our components that we get earlier in the matrix form. So as we can see in here, the R components should always be on top of the F components. So this middle thing in here, the value in the middle right here are the components of the RCA. So at the bottom right here are the value of our FBA. So in solving the matrix, we are going to multiply it diagonally. So as we can see in here in the figure, to find our I hat and j hat and k hat, we are going to multiply it diagonally and subtract it by the red line. So in solving this, we will get MC is equals to 108 minus 1944. So how do we get 108? So we get 108 by multiplying the I hat diagonally. So what I mean is that I hat is equals to negative 6 times negative 18, which equals to positive 108 minus negative 18, 54 times 36 also in the I hat. So factoring out I hat, we will get 108 minus 1944. So in the I hat we get j hat we get negative 108. So how do we get negative 108? So in the j hat we also multiply it diagonally. So j hat is equals j hat 36 times 36 times negative 3. So we get negative 108 j hat minus negative 18 times 48 times j hat. So we get negative 864 j hat. So if we're going to factor j hat, we will get this equation. So negative 108 minus negative 864. So for our k hat, we get 2592 minus 18. So how do we get 2592? So for our k hat, we also multiply it diagonally. So k hat multiplied by 48 multiplied by 54 will get us 2592 k hat minus negative 3 times negative 6 times k hat, which gives us positive 18 k hat. So factoring out k hat will get us 2592 minus 18 k hat. So if we're going to simplify this equation, we will get our final answer, which is MC is equals to negative 1,836 pounds inch in the I hat plus 756 pound inch in the J hat plus 2,574 pound inch in the K hat. So this right here right now is the answer of our question. So this right here is the moment of C exerted of the force exerted in the point A. So that is all for today, and thank you for listening to my video.